All right, so good morning, everybody. Today we're going to be going over the Unit 4 review in your packet. The test is on Thursday, so please make sure you pay close attention to this and make sure that you do tonight's homework so that you're ready and prepared for Thursday's test. Now, you should have already had a moment to try out numbers 1 through 5. So right now, this is really you just checking your answers. So for number one, it says triangles have angle measures that add up to 180. So they said create three measures that make a scalene triangle. Now remember, when you're looking at your word wall, it says that a scalene triangle has no congruent sides. Now, if you look at the picture, it also shows that none of the three angles can be equal to each other. In a scalene triangle, all angles must be different as well when you look closer into that picture. So we get to pick any three random angles here. So there's really, all of us should probably have a different answer. Just remember, they officially need to add up to 180 to be a triangle, but scalene means they all need to be different. So here we go. Let's say I make this one, my first angle 30 degrees, and then I make the next one 70 degrees. So that already is 100. And of course, if I add another 80, look at that. All three angles are different, but they still add up to 180. Now, the next one says it's an isosceles triangle. So if I look at my word wall and it says an isosceles triangle has two sides that are equal. But remember, if it has two sides that are equal, it also has two angles that should be exactly the same. So if they need to add up to 180, as we've mentioned in the past, well, let's see, two angles need to be the same. So I'm going to go with 50 and 50. Again, not all of us have to have the same numbers. Just have to make sure you have two of them that are the same. So that's 100. Well, then I'll just make this one 80, and there it is. Look at that. Two angles that are equal, and they add up to 180 with that extra 80 there. And then this one says it has to be a right triangle. Now, when I'm again looking at my word wall, a right triangle says that one of your angles has to be a 90, but just one. So then if it's a right triangle, I'm going to make one of them a 90. Don't forget, they still need to add up to 180. So now I can just pick just about anything I want over here. Let's say I make one 50. So that's 140 now. And then, of course, I'll make my last one 40 then. And there we go. We have a right triangle because of the 90. The other two angles, that doesn't really matter what they are as long as all three add up to 180. Now, looking at number 2 here, we still have the space for it without moving this paper. Use the diagram below to answer the following questions. Name the theorem used to solve for x. Well, notice we have one angle, there it is, measures 90. We have two angles. They want me to find a third angle. Well, when we add three angles of a triangle together, that's what it's called. So, again, for a lot of these types of questions, the answer's in your word wall. It's the triangle angle sum theorem. The triangle angle sum theorem. We'll just write THM for short. And then it says, all right, well, then find me the value of x. Well, the rule says that all three angles, so the x, the 90, and the 57, all added together, should give me a grand total of 180 degrees. So let's see. X plus, so now we'll use our calculator here, and 90 plus 57 is 147, which is equal to 180. We subtract the 147. We can check our numbers with a calculator if we need to. So then x is equal to, let's see, it ends with a 3, 7, so 33. And we have our answer for x. Now, so that I don't have to move the paper around too much, we're going to do number 4 since it's already here and ready to go. So for number 4, it says in the triangle, WX is congruent to segment XY. So segment WX, I'll put a tick mark on it, is congruent to XY. Now remember, look at our rule that we've learned here. The base angle theorem says if you have two sides that are equal, well, then you have two angles that are equal. but you always look for the base. Notice the base is the side that isn't marked. So when I'm looking at this picture here, this is the side that isn't marked. So that makes this the base. And if that's the base, then this is a base angle. And this one's a base angle, which means we can call this a 35 right there. So it says, what theorem is used to find the missing angles? Okay. We just saw it. It's the base angle theorem. And the base angle theorem just helped me find angle Y. So now I know that the measure of angle Y is also 35. But if they want me to find the measurement of angle W, which is up here, right at the top there, well, you see, now we need to bring in a different rule. So not only am I going to use the base angle theorem, I have to use the one we just talked about earlier, the triangle angle sum theorem. And that's the one that says that if I add all my angles, I'm going to call it just W for short, plus the 35 plus the 35, it should add up to 180 degrees. So let's finish the math here. 35 plus 35 is just 70, is equal to 180. And I know the picture doesn't really look like it, but when I find angle W measures officially, let's see, 110 degrees. I know picture-wise it doesn't look like it, but mathematically speaking, that's our answer for that problem. All right, so let's keep this going here. Again, we are using our word wall as much as we can. And so here we have number 3 and number 5 ready to go. Now, when I'm looking at number 3, it says, find me every single angle that's missing, C, D, and E. Well, look, D is by far the easiest for one reason. If this is 58, remember, this one's right across from it. We call those vertical angles. So then angle D is also 58. So we're going to take care of that one immediately. The other one that's also easy to spot is this one right here. Look, angle E. This is one way of doing it. Look at that blue mark and this purple mark. We've seen that mark before. When we make a straight line with two angles, this is called the linear pair. So when you have a linear pair, we know that the 58 plus angle E, I'm just going to write E, should make 180 degrees. So that all I have to do is subtract the 58 from both sides. And just like that, we're about to find out that E is officially, let's see, we're going to make that a 10. So that's a 2. So 122. And again, use a calculator always to double check your numbers. But we have E right there, 122. And finally, we also know that the three angles of a triangle, look at that. We have that blue one. We have that 61 right here. And we're looking for angle C. We know that these three right here will always add up to 180. Yes, we're ignoring those. We don't need those. We're looking at the inside angles. So if that's the case, for angle C, C plus 58 plus 61 is equal to 180. Add the 58 and the 61. We're going to combine our like terms. So that's 119. And then, of course, all we're going to do now is subtract the 119 from both sides. And so C is equal to, let's see, 180, 61. And just like that, we have every single angle that we were missing. All right. And then there's number 5. So just give you a moment there. Again, you really should be just checking your answer, but if not, hey, write it down. This is your study guide for the test. Now, take a moment. You're going to try page 38. Once you try page 38 for a few minutes, we'll play the video again so that we can check your results. All right, so let's see how you did on this side. In triangle ADE and CBE, it is given that AE is congruent to CE. Remember, they give me information. We're going to mark it. AE is congruent to CE. And E right here is the middle of DB. So now remember, this is DB over here. They said E is right in the middle of DB, but remember, when they use a vocab word for us, that means I need to find two things that are equal. Well, again, don't look everywhere. You need to only look at the highlighted, and the only two parts that are equal to each other are this one with this one. Again, your marks need to be on your highlighted line. And when we look carefully at the picture, we can say, all right, well, there's something else that we can mark here. And the only other thing that we can mark is vertical angles. So vertical angles are always equal to each other. Now, this is what the question is going to look like on the test. They're going to say which rigid motion transformation will validate the SAS. Not like number 5. That one, like I said, had too many typos in it. Now, for this one, it says, how can you turn which rigid transformation will validate the SAS? Again, this is not about SAS. We already see SAS there. What they want me to do is they want me to do things to ADE. So they want me to work with this one so that it lands perfectly on top over here. Well, think about it, right? They said, what if you rotate? That's a spin, ADE. So if I were to spin this triangle, we want it to land perfectly on top of this one. And they said, well, what if you spin it right on the letter E? Well, think about it. If I spin it this way, right, or the other way, it doesn't matter. That spin will land perfectly right on top of this triangle. So they said, which one will work here for us? Well, a rotation will, a little spin will do it. And I'm not saying this side is going to land here, right? We're talking about taking that triangle. So let me show you here, a little visual for you, just really quick. Now, we want it to land perfectly on top. Now, I know this isn't the right size here, but it'll get the idea going. See, they want this triangle to land there. So if this is the single and this is the double, and they said spin it right here, see, as we spin it around right on that point, see, the single does land with the single and the double lands with the double. That's why we know this rotation is the one that works. But that's why you're going to be using patty paper, which clearly I don't have with me right now. Now, since it's here we go again. Rigid motion is the big topic for today. So it says, give the rigid motion transformation that maps this triangle on the left onto the triangle on the right. Now, these are the three words I have to pick from. Rigid motion just means I'm going to either flip. Is it a flip? Is it a slide it over type of situation? Or do I spin it? Well, think about it. If the three marks are already there and I want the marks to be in the same spot, then all I have to do is just slide it over to land perfectly on top. This is why this one is a translation. And then here, if I want these marks to land perfectly on top of these, well, then all I have to do is flip it over. And if all I have to do is flip it over, then we call that a reflection. And then when the orientation of the triangle changes completely, that's when we know maybe there's a point here somewhere that we're going to spin it around. And if we spin this triangle around, just kind of like what we saw earlier, right? If this is the triangle right now, well, then if I spin it, it'll land perfectly on top of that one. And when we do a spin, then that's what we call a rotation. Again, this is going to be one of the big concepts on the test, but this is what the questions are going to look like. Not so much like number 5, luckily. All right, let's see. Number 7. Now, number 7, it says again, which transformation will map? Remember, map means this is going to land perfectly on top of this one to prove that they're congruent to each other. So again, it's not about congruency. They just want me to make sure that whatever moves they ask me to do, it's going to land perfectly on top. So this is a straight out patty paper type of question. All of these are. It says choose all that apply. So I want that triangle to land perfectly on top of this one. Now, again, the tough part is not having that patty paper. All right, so I found something that'll work here for us. So let's see how it goes. All right, it says which transformation will map ABC onto XYZ. All right, so I'm gonna trace ABC there. Mapping means it needs to land perfectly on top. So it says do a rotation of 90 degrees clockwise about 0, 0. Okay, so here's 0, 0. There's our little plus sign that we're used to using. And now I'm going to spin it. It says 90 degrees clockwise. So with the clock, 90 degrees. So there's the plus sign. And just like that, well, look at that. It landed perfectly on top of it. So, yes, this one worked, but they said choose all that apply. So we're going to try all of them. They said, well, what if you draw a reflection along the x-axis? So if I were to flip it along this line, let's see here. If I were to flip it along that line, now that little plus sign will help me there. So if I flip it over, nope, it did not land perfectly on top. So that doesn't work. Again, mapping means it lands perfectly on it. Rotation of 270 clockwise about the origin. Okay. They said 270 counterclockwise. So that means I'm spinning this way, but 270 means I'm going to spin this thing 3 times. So here we go. There's 1, there's 2, and then there's 3 right there. And yeah, look at that. Lands perfectly on top. So that one worked. And we're going to try the last one, a rotation of 90 degrees counterclockwise about the origin. Well, we already know it took 270. If all they have me do is just move 90 counter, yeah, that did not land perfectly on top. Again, mapping means it's going to land perfectly on top of the other. All right, so look, now I can show you this one here from earlier. They said rotate ADE. So here's ADE, ADE. And they said rotate it about the point E. So if I'm right here, notice there's that single, there's that double. They said if you were to just spin it, so there's the spin. And then if you notice, 1 and 2, oh, just off by a little there, huh? Looks like it. Unless not drawn a scale, maybe. Yeah, so there's that. Translated means it would have to stay in the same direction. That's why translation doesn't work. Reflection across a point can be very difficult because if I just flip it along the point, look at that, the double and the single don't match up anymore. And then rotate it about point D. They said, well, what if you spin it on this point? Will it land perfectly on top of this one over here? No, that's why A was the only one that made sense. All right, but finally, number 9. LQP was rotated about point Q to form triangle MQN. Which of the following statements must be true? Now, here's the issue. If, right, they said this was rotated to form this triangle. So what they're letting me know is that LQP has to be congruent because it was a rotation with triangle MQN. Here's the thing. The picture is going to throw you off. Go by the order of the letters. Remember, order matters. And so it says LP, LP, first and last. So LP goes with MN, and that's exactly what they have. So the order is correct. This is a question about order. Look at the next one. Angle P. Okay, so P, well, we already know who P should go with. P has to go with N. Hey, that's exactly the letter they chose. So then that's another correct one. Then they said L with Q. So the first 2 letters, well, then it better say MQ. And no, that doesn't say MQ. That's why that's wrong. And finally, one more. It says PQ. So the middle and the last letter. So then it should go with NQ. And look at that. Wrong letters again. That's why those are the only two answers that go with each other. Remember, it's better to look at the order of the letters because order matters when you're talking about congruency than to look at the picture, which may throw you off. All right, so we're going to pause the video here one more time, take a moment, of course, and start working on the next page. All right, it's time to check your answers. For number 10, it says use a diagram to answer the questions below. Describe the single transformation that maps GPT. All right, let's copy GPT. So GPT, there's the 90. We bring in as many details as possible so that it'll help us. And they said, you're going to move it here. Well, notice the order of the letters didn't change. So if you notice, check this out. All I would do is move it to the right. And it looks like I would only move it 2 spaces to the right. And 1, 2, 3, 4 spaces down. But look, we didn't spin it. We didn't flip it. That's why this is called a translation. So describe a single transformation that maps it. This was a translation. And look, we're going to look at the point T again. It was 2 to the right. And it was 1, 2, 3, 4 spaces down. Just like that, we're done. But this was a translation. Then the question says, all right, well then, once you were here, how would you make it become this one right there? Okay, well, look, we were already there. They're saying, how would you turn it there? Well, look, it's definitely not a slide because the triangles wouldn't match up. Is it a flip? Well, let's see. If I flip it over, nope, that would not land perfectly on top. So then this must be a rotation, where this is going to be a spin. So this is going to be a rotation. The question is, how much and where? So that's what makes this a little bit tougher. See, if I spin it on the origin, let me try that first. Spin it on the origin. No, not quite. So maybe it's not going to be the origin there for us. So the only other spot that I can think of is maybe halfway through here. Look at that, where the G and the G are. Halfway through, see that's, oh, let me put that little plus sign there actually. This would be a spin of 90. Another 90, and look at that, there it is. Landed perfectly on there, but it took 2 spins of 90. So then it's a rotation of 180 degrees, right? But we have to say where. About. Now look at the point that we spun it on. We said it was kind of here's G. It was right in the middle, which means it's -1, -2. That's the spinning point. Okay. And of course, let's keep it going here. Number 12, it says angle X and angle Y are the same. All right, we just talked about this rule earlier. We said if you have 2 angles that are the same, then that must make this the base. So when we ask, well, if 2 angles are the same, I have to have 2 sides that are equal also. That would be these, never the base. And then it says XY is 11. Okay, this side is 11. WY is 19. This is 19. Well, then let's not hesitate. I already know what WX is. If this is 19, this is 19. And then they said WX is 4X plus 11. So 4X plus 11 has to equal that 19 that we already have there because they're equal to each other. So 4X plus 11 is equal to 19. Subtract the 11. 4X is equal to, what is that, 8. And then when I divide by 4, X is equal to 2. And there's our answer. And it says explain. Well, this was the base angle theorem that we mentioned earlier. All right, looking at number 13. Yeah, we see it again. Look at this. 1 angle, 2 angles, 3 angles. Says find the measure of all 3 angles, justify your answer. Well, we know what the 3 angles of a triangle need to add up to. The 4x minus 23 plus the 2x down here plus the 5x minus 6 has to equal 180 degrees. We are going to be using the triangle angle sum theorem. All right, so we're going to combine our like terms. 4x and 2x is 6x minus 23 plus 5x minus 6. That's just me combining these two so far. Just wanted to get a smaller look at this value. 6x and 5x, well, that's 11x. But let me get these going. Negative 23 and negative 6, well, that's negative 29. I should have just combined it all earlier. All right, we're going to add the 29 to both sides. So 11x is equal to, there's a 209. All right, and then when we divide this by 11, x is equal to, let's see, that should be, I believe, 19. Yeah, just a 19 there. All right. Now we know what x is, but they said, hey, solve every angle. All right, I need 3 angles. Look, this is the easier one right now. All I have to do is multiply it by 2. So 2 times 19, we're looking at 38 degrees. There, we've got that first one. I'm going to put a 19 here. So 4 times 19 minus 23. Now, of course, we're going to let the calculator handle this for us. And the calculator says on Desmos that this is 53 degrees. And then finally, we're going to put a 19 into this one here, minus the 6. So we're going to let the calculator do this for us on Desmos, and we get an answer of 89. Now, there is a quick way that we can check and make sure all of our answers make sense. Remember, all 3 of these right here need to add up to 180. So let's double check. So 89 plus 53 plus 38. And yep, calculator says they add up to 180. Now, let's move on to these last 2 questions on this page. Gustavo says that the triangles are congruent according to ASA. Remember, order matters. AS has to be right in the middle of the 2 angles that are marked. So here's a 60, here's a 50. Here's the 60, here's the 50. The question is this angle right between, is this side right between the 2 angles? And the answer is no. If the side were right between the 2 angles, it would be touching both angles. Look at that. This blue line only makes contact with this one. So Gustavo's incorrect because the side is not between the 2 given angles. Right? Remember, order matters. S is right in the middle of the 2 letter A's. This side is not between this A and this A, right? Clearly, we should be able to see that there. All right, and finally, when we're looking at number 14, it says, use the diagram below. All right, write 2 different equations that can be used to solve for x. Give a reason for each one. Well, first of all, look at this. 1, 2, 3 inside angles. We know what the 3 inside angles add up to. 5x plus 7x minus 10 plus 6x minus 8. There's all 3 of them. Should add up to 180. They said, give me a reason. This is called the triangle angle sum theorem. Again, it's in the word wall. You forget what the name is. Then they said, well, give me another equation. Well, I notice that they have an angle on the outside. Now, remember, we have a rule for when there's an angle on the outside. It's called the exterior angle theorem. And it says to get the outside angle, all I have to do is add 2 interior ones, but never the one right next to it. So if I want to get that outside angle, that 12x minus 7, all I have to do is add the 2 inside angles, here they are, that are not directly connected to this one. So I'm going to add the 6x minus 8 plus the 7x minus 10. And again, that rule was called the exterior angle theorem. All right. Now, eventually it does say, hey, find me the measure of the exterior angle. Well, I have to pick one of these two. This one actually looks maybe a little bit easier than the others. Maybe the 181 does. We've been using that one a lot anyways. Yeah, let's use that one. 5x plus 7x minus 10 plus 6x minus 8 is equal to 180. I know they said find the outside angle. All I need is x first. So let me just combine everything. 5x plus 7x, that's 12, plus another 6, that's 18x. And then, of course, I'm going to combine the negative 10 and the negative 8. Well, that's negative 18 is equal to 180. Next thing I do, of course, is add the 18 to both sides. And once I add the 18 to both sides, 18x is equal to 198. And here we go. We're going to divide by 18. So get that calculator handy. 198 divided by 18 is 11. So even though we have the answer for x, that's great. They said find me the exterior angle. So my exterior angle is 12. The x is 11 minus 7. Then let's let the calculator do the work for us there. This is the answer they want for letter B up here. So 12 times 11, and then I'm going to subtract that 7, and there's my answer, 125 degrees. All right. So take a moment and work on that last page of the day for the classwork here that you're doing. Even though you're getting the answers, so you can check them after, that's fine. But I need you to work on page 40 for a moment. All right, so let's check your answers here now. So again, you needed to have pause the video there so you could try it out yourself, but here we go. Now, it says, what are the 3 ways to prove that triangles are congruent? Well, if they want me to prove that triangles are congruent to each other, all I have are side, 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 angle, side, and of course, angle, side, angle are my 3 options. And then that's it. Easy answer for us. Now it says, if ZT, so that's this one, if ZT is bisecting STV, it's an angle. So notice, here's STV. This is what got cut. But you have to understand that when they use a vocab word like bisect, midpoint, that, it means you need to find something to mark that's equal to each other. So if this is the angle that got cut, well, then these are the 2 little angles that you should be marking. That's what we get from that. Then they said triangle STZ and VTZ are right triangles. They just said these 2 triangles are right triangles. That means it has to have a 90 in it. Well, that angle doesn't look like a 90, but this one does. So it has a 90. It has a 90 right there. And don't forget, there's something that we can mark because we know for sure that it's congruent. And that's this side right here. They're sharing that line. Remember, it's called the reflexive property. So now the question is, well, are the 2 triangles congruent? Hey, these are my 3 options up here. And look at what we have. We have an angle, we have a side, and we have an angle. And look at that. The side is right between them. So yes, it passes the ASA test, the congruency theorem test. So all we have to do is name it, but order is very important. They said S is first. Well, S has no mark. Well, V has no mark either. So I'm going to start with V. T is next. Well, it's also a T for that one. And then, of course, I would end it with Z. Remember, when you're talking about congruent triangles, it's all about marking, and then labeling, right? Now, let's look at the next one here. Let's see what test number 17 will pass. So it says HJ is congruent to KJ. HJ gets a mark, KJ gets the same one. GJ, so this one right here, is going to cut, right? It's going to bisect, going to cut right in half, HJK. So we're going to trace it, HJK. So this corner got cut. But if the corner got cut, right, this angle, then you should be marking two little angles that are congruent to each other. That's the whole point. It's all about marking. And then it says complete the statement. But there's one more thing that we can mark ourselves. When they share a side, we should already be marking it automatically. This is the reflexive property. And look at what we have now. I have a side, I have an angle, and I have a side. And yes, the angle is right between the two sides that are marked. So, yes, this is officially passing the SAS congruency theorem, which means I can now name it in the right order. H is first, so that's up here. Well, then K should be first. J is the next letter, so they went HJ. So if it's J here, then this triangle also goes with J. And then the last one is G. It's all about marking. And once you mark it, don't forget, you got to find the one that you can mark on your own. In fact, look, for number 18, I'm going to start it off with that. There's one side that I should mark instantly, and that's this one right here. Why? Because they share it. Now, they also mention AB is congruent to AD, so AB gets a mark, AD gets a mark. Same one, they said it's congruent. They said AC bisects, all right, someone's about to get cut right down the middle. It's whatever's after the word. So they're saying BD got cut. Well, BD is a line. And if you have to put marks on it, well, then the only thing that's equal is BC is the same as CD. Those are the only two pieces on there. And I think it's obvious which test we're going with on this one. This is passing the side congruency theorem. So now it's all about order. They said A is first, ACB. So they went this way, ACB. So they already named this one for me. I'm naming the other one next to it. But if they called it ACB, well, then I should call my triangle over here ACD. Very similar letters. All right, two more to go. Let's see how you did. Now, for number 19, it says, got to mark things. A is congruent to B. All right, there, we marked that thing. You know what, though? We should have marked something instantly, and that's the fact that vertical angles are always equal to each other. And look at what we have so far, right? If I have my list of tests that I can pass or that I can use, look at what we have marked. One angle, two angles. This is the only test that I'm hoping is going to work. And then they said E is the middle of AB. Remember, it's always whatever's after the word that gets the marks. It's a segment AB. This is what needs to get marked. And I'm not talking about marking the entire thing. This triangle, I'll put a mark here because that's highlighted. And then I go like this, and I can put a mark on this one because it's highlighted. You can only work with that. And there it is. Look at that. The side is touching both angles. So ASA officially works for this one. The congruency theorem, that's the test it passes. Now it's all about order. They started with A. A has a purple single mark. B has a single mark, so I'm going to start it with B. Then they went with the letter E. Well, it's right in the center. It's vertical. So then this one also has an E. So it's BEC that needed to be named. All right, now we're down to our last problem here where we're going to do our proof. And for this proof, it says use the proof below to show that YW bisects XY and XWY is congruent to ZWY. Then triangle XWY is congruent to Z. All right, so we're not used to a proof like this, but look, this is the given. Like I said, I'm not sure why it's written like this, but it says XY bisects this. These two angles are congruent. That's what they are given, or that's what we are given. So that's why when it says this, I'm just going to say the word given. But remember, the only thing that's congruent here is this one. This is the only thing that's actually congruent. And notice how it has an angle symbol. So I have an A so far. So side, by the way, is already out. These are my only options I have. And that's an angle. XWY ZWY. They both have W in the center, so that means this is the angle they want me to look at. All right, we got our first one there. But I also noticed that they used a vocab word. And remember, we've talked about this. This is who's getting cut when they say bisect. And it's not a side, it's an angle. So that's why my reason is going to be the definition of angle bisector. Why? Because it's an angle symbol and they use the word bisect. So, definition of angle bisector, but look, they said XYZ is the one that got cut. If this is the big angle here, if this is the corner where the cut happened, then you're supposed to name this angle. So let me name it first. X, Y has to be the middle, W. So X, Y, W. And then I have to name the one next to it, which is W, X, Y, Z, or Z, Y, W. Z, Y, W. Well, look, I have two angles, so SAS is gone. And of course, look at that. They share the side in the center. That WY, they both share it. So WY is congruent to segment WY. It's a part of a triangle. When you repeat itself, it's called the reflexive property. And now the question is, do I have three congruent statements? Absolutely. Look, I have an angle, I have a side, and the side is touching both angles. Right there. ASA is my reason. ASA, congruency theorem. All right, everybody. Next thing you need to do now that we're done with this review, this classwork, and you get your points for it and all, you need to make sure that you're working on tonight's homework, which is your second practice of the test. You saw a lot of the test questions just now. Let's get more practice in by jumping onto page 41 and starting to work. And it's the same kind of problems we did earlier. So get that word one. In fact, look, we just answered this question. This was number 15 on the one we just did. So go for it. Very similar to what we've done. Get the word wall, use it. Get a patty paper, use it. But let's get ready for this test. Have a wonderful day, everybody. I'll see you on Thursday.